Hello, dear students. This is lecture number 2 of quadratic equation. In first lecture, we have learned that how to complete a square of a quadratic function. That if we have y is equal to x square plus 4x plus 6, then we have learned in previous lecture that how to complete a square. For example, if I give you example, y is equal to x square plus 4x plus 6, then completing square is just x plus 2 whole square minus 4 and plus 6. Then this will become x plus 2 whole square and plus 2. So in this lecture, we will learn that how to draw the curve of a quadratic function. So the standard form of quadratic function is I think you know that y is equal to ax square plus bx and plus c. This is the standard form of quadratic equation. So the graph of quadratic equation is always a U shape or open upward or open downward. So when it will be open upward and when it will be open downward, if the coefficient of x square a, this thing, is positive, then it will be open upward. Mean a greater than 0, then it will be open upward. If a less than 0, then it will be open downward. Just take an example. We can draw it through Desmos. Like if you look at this, f of x is equal to x square plus 4x plus 2. So this is a graph of f of x is equal to x square plus 4x plus 2. So if you are looking at this green curve, so it is open upward. If I just change the sign of x square, it will open downward. So this sign actually decides that whether it will open upward or open downward. So by changing other sign, you will see that there will be no change. For example, minus 4x, if I change this plus to minus, so remain same, open upward. And if I change also this sign minus 2, so same, just only you will see a small difference in its position. So the graph open upward or open downward, it is decided just only by this coefficient of x square. If it is positive, then it will be open upward. If it is negative, then it will be open downward. So now we will learn that how to draw a quadratic curve or how to sketch, not drawing, but how to sketch, because we have already learned this, how to draw a quadratic graph of quadratic function in O level. So now in A level, we will learn or in advanced, we will learn that how to sketch a quadratic curve. So there are actually two types. In type 1, sketching through vertex and y-intercept. So when we com change the quadratic function into complete square form, then it will look like this: x minus h whole square and plus k. So h and k is the vertex of quadratic equation. This is a standard form of quadratic equation in complete square form. X minus h whole square plus k, where h and k is the vertex of quadratic equation. What is a vertex? If a quadratic curve is like this, then the minimum point which which divides quadratic curve into two equal parts, this is called the vertex of quadratic function. So if we draw open downward, then this maximum point is called the vertex of quadratic equation, okay, of a quadratic function. This is called vertex. So h and k, this is called vertex. So this is called vertex. So and this thing, we know that how to find a y-intercept just by putting x is equal to 0. For you have learned that how to draw the graph of linear equation. Then the linear equation where this line crosses the y-axis, this is called y-intercept, and where this line crosses the x-axis, this is called x-intercept. So these all things we have already discussed in O level, y-intercept and x-intercept. So I hope you got all these things. So moving on, just let me give a 1 second, please. Plus k. First, this is type 1, that if we have a graph in complete square form, then how can we draw? Now, let's take some example. Like if a function is y is equal to, I'm going to take this example number 1, question number 1, x square plus 4x plus 6. So if you convert this into complete square form, it will be x plus 2 whole square plus b square and plus so no, not plus but negative 4 and plus 6. So x plus 2 whole square plus 2. So compare it with this standard form of complete square quadratic function. So it is y is equal to x minus h whole square plus k. Now you can find the value of h and k. This would be minus h is equal to plus 2. So h is equal to 2 by minus 2, sorry. H would be minus 2, while plus k is equal to plus 2. So k will be 2. So this is a vertex of quadratic equation. So how can we find the x-intercept? Just by y-intercept, just by putting x is equal to 0. When you put x is equal to 0, at x is equal to 0, y will be 6. This is, or you can simply write this one. Y is equal to 6 is the y-intercept. So now look, how can we draw this one? Just or how can we sketch this quadratic function? So this is a vertex of a graph. Look, first and the coefficient of x here, it is positive, so it will be open upward. Now the vertex of the graph is x coordinate is minus 2 while y coordinate is 2. So here is origin 1 2, this is the negative 2, while y is plus 2 1 2. So this is the vertex of quadratic function, while the y is 6, y-intercept, where this graph crosses this y-axis. So 1 2 3 4 5 and almost here. So you can draw this graph like this here, and you can mention this as a 6, while this you can mention minus 2 and plus 2. So this is the vertex of this graph, while we can say that this is a way we can sketch the quadratic function graph through complete square form. So take one more example, like x square plus 12x plus 3. So y is equal to x square plus 12x plus 3. So when we convert complete square form, it will be x plus 12x, sorry, plus 6 whole square minus 36 and plus 3. So x plus 6 whole square minus 33. So the write down the original or standard form of complete square, x minus h whole square plus k. So minus h is equal to plus 6 and h will be minus 6, while plus k is equal to minus 33, or you can say that k is equal to 33. So h is equal to minus 6 and k is equal to 33. This is the vertex of quadratic vertex is minus 6 and 33, while this is 3 is the not 3 but yes, when you put x is equal to 0, then the y-intercept would be 3. So y-intercept is equal to 3. Now draw this graph. I'm using Desmos software. X square plus 12x plus 3. Just here I'm changing x square plus 12x and plus 3. So if you're looking at this, so this is a way how we can draw the quadratic, because on white, so this is a vertex. Here it's you are looking at this, the -6 and -33, while is this is y-intercept, which is 0 and 3, mean this graph is crossing the y-axis at 3. So now look at this. Uh, this is -33. I just made a mistake here. -33. Now you can make this like so. If, because this is a small space, so you can scale this one. So if I consider this 10 and -20, -30, -10, -20, -30, so here it would be 33, while 2, 4, and 6. So this is -6 and -33, it would be here. And when you draw the curve of this function, and here it would be 3. So it is like that. While here in this way, you can draw the quadratic function. This, and mention here this -6 and -33 vertex of a quadratic graph, while this one is 0 and 3 is y-intercept. This is type 1. Then we can draw the quadratic graph. In type 2, how can we draw the graph by using type 2? If you look at the type 2, sketching through x-intercept, how can we find the x-intercept if we have function and that can be factorized? Y is equal to x square minus x minus 12. So if this function can be factorized, and or you can make factor, then it will be x minus 4 and x plus 3. So by using these factor, or by using these factor, you can find the x-intercept by putting y is equal to 0. So x will be 4 and x will be minus 3. If this function is not cannot be factorized, then you can use Pythagoras quadratic formula as well. So look, -3 here, if I put this is -3, while 4 is here, by simply using an the vertex of this graph should be in between the -3 and 4, and this is equally lie between half of this distance. So just -3 to 4, it will be here 0 and -1. So no need to mention vertex in this situation. Just draw a curve like this, and x square is positive, so it would be open upward. So in this way, you can sketch the graph of x square minus x minus 12 by using x-intercept. So there are two ways, I said, by using vertex and y-intercept. The other way is by using x-intercept. So takes one more example, like we have y is equal to x square minus x and minus 6. So if now I change this whole thing and minus x plus x and plus 6. So write down here 6 plus x minus x here. So the factor of this would be, first multiply this would become minus 6x here, and plus minus 3 and plus 2. So the factor are 2 plus x, not just 1 minute please, 6 plus 2 plus 3x, and then minus 2x, because this is positive, so x 3 will be positive while 2 will be negative. So 6 plus 3x minus 2x. So take common minus x square. So 3 is common, 2 plus x minus x is common, and 2 plus x. So it will be 2 plus x and 3 minus x. So the x-intercept are x is equal to minus 2 and x is equal to 3. So just how we draw this, x is minus 2 while and 3, minus 2 and 3. So now look at this because the coefficient of x here is negative, so now it will open downward. So just make us curve open downward and sketch it. These are the x-intercept minus 2 and 3 while this curve open downward. This is just all about quadratic sketching, that how can we draw or how can we sketch the quadratic function. Okay, the next is the maximum and minimum value in quadratic function. So remember one thing, we are always find the maximum and minimum value of quadratic function after converting it into complete square form. Y is equal to x minus 2 whole square minus 3. This is a function, a quadratic function. So first sketch this. Its vertex is minus, when you put vertex is 2 and minus 3, while how can we find the x-intercept? Just by putting y-intercept, x is equal to 0, minus 2 square would be 4, 4 minus 3 is 1. So the y-intercept would be 1, while 2 and minus 3, 1 and 2, 1, 2 and 3, this is minus 3. So this graph would be like this one, because it open upward because the square of coefficient of x square will be positive if you open this, so it will be open upward. So vertex is, you can 2 minus 3, and its y-intercept is 1. So if the graph is open upward, then examiner always ask for minimum value because there is no maximum value in this graph. You can increase these two line up to, it is just up to you. If I increase this and I increases up to 1000, 2000, 3000, there is no limit. But we cannot shift this graph downward. From this is the ending point where y is minus 3. This is a minimum value of this graph at x is equal to 2. So in this case, he always asks for minimum value of the function. So there are two types of question. In one, he always asks the minimum value of the function. So if he asks the minimum value of function, then you have to tell him the value of y, minimum value of f of x. It means we have to f of, we know that this f of x is equal to also equal to y. So it means he's asking for value of y. So minimum value of f of x mean its minimum value is minus 3. Okay. And if he asks where this minimum value exists or for which value of x this minimum value exists, then you have to answer that it exists at x is equal to 2. So I am repeating my words again. There are some sort of confusing question. Then sometime he asks where this minimum value exists. If he asks where, then you have to answer the value of x, that x is equal to 2. If we ask the minimum value of f of x, then remember that this would be negative 3. That minimum value of f of x mean minimum value of y. So one more function, that if the x square coefficient would be negative, a function like this whose a vertex is, for example, 3 and 4. 3 and 4. So in this case, when x square coefficient is negative and this graph opened downward, then he always asks for the maximum value. Find the maximum value of the graph. Then how can you reply that the maximum value of f of x would be 4? And if he asks where this maximum value exists, then you simply reply that at x is equal to 3, the f of x is maximum. That f of x, the value of f of x will be 4 at x is equal to 3. So this is just all about sketching, trying, and minimum and maximum value of quadratic function. So now we are going to take example that how can we find minimum or maximum value. That question is that find the minimum or maximum value in both question. If there exists a minimum value, then find that. If there exists a maximum value, then find that. 2x square minus 8x plus 6, I said first convert this equation into complete square form. So we have 2 here. So first divide this whole equation with 2. So it would become x square minus 4x plus 3. Now convert x minus 2 whole square minus 4 plus 3. So it would be x minus 2 whole square minus 1. And in last step, multiply this 2 on this side. So 2 into x minus 2 whole square minus 2. So first look at this, because x coefficient of x square is positive. So the curve will be open upward. So, then the second you have to find vertex. So vertex is, I'm not going to write down writing down its standard form, just writing directly. H will be, because minus h is equal to minus 2, here minus h is equal to minus 2, h will be plus 2, and then plus k is equal to minus 2, so k will be minus 2. So vertex is 2 and minus 2. And you know very well this is the value of x, and while this is the value of y. So in this case we have minimum value because graph is like this, open upward. So in this situation vertex is this 2 and minus 2. So we have minimum value if graph is open upward. Minimum of f of x will be 2. And where this minimum value exists, x is, no, not minus 2. And where this exists, x is equal to 2. Okay. So now look at this. 6 plus 5x minus x square. First arrange this. Minus x square plus 5x and plus 6. Now multiply minus 1 with whole equation. Then this would become minus y. X square minus 5x and plus minus 6. Change into complete square form, x minus 5 by 2 whole square and minus 25 by 4 minus 6 minus y, and it would be x minus 5 by 2 whole square, and 4 6 times 24, it would be minus 49 by 4. And last of all, you have to multiply this negative sign on this side. This would be minus into x minus 5 by 4 whole square. And this would become plus 49 by 4. So the vertex in this situation would be minus h is equal to minus 5 by 4. This would be 5 by 4. And k, a value of k would be 49 by 4. So because we know that here the coefficient of x square is negative in original function, so the graph would be open downward and the vertex is here 5 by 4 and 49 by 4. So in this situation we have maximum value of f of x. So write down the maximum value of f of x, that max of f of x, it is 49 by 4. And where this value exists, x is equal to 5 by 4.